Okay, example 11, a cut of mass M, so here we have, is attached to a spring with force constant K. Now, initially the cut is at equilibrium position. This cut is now displaced a small distance x, so this cut is pulled a distance x to the left, and this cut is released and allowed to undergo oscillation. So you oscillate left and right about the equilibrium point here. Okay, the question is, show that the oscillation is simple harmonic and then express the period t in terms of m, k, and x. Okay, so that's the question. Okay, how do we show that this oscillation that is going to take is simple harmonic? Well, to show that an oscillation is simple harmonic, all we need to do is to figure out what's the net force acting on this cut right now, and show that to get a formula for this net force, then show that this formula is actually proportional and opposite to this x. If you get a formula that is negative something times x, then that will show that the oscillation is going to be simple harmonic. Okay, so that's what I'm going to do now. What follows here is actually the solutions. Okay, the part of the solutions. So remember, our first step is to figure out what is the net force acting on the cut. And then from the net force, we'll deduce the formula for the acceleration and show that the acceleration is proportional and negative of x. Okay, so first, before we figure out the forces, we follow some sign convention. It's either we take right or left as positive, but since in the beginning, okay, there's okay, here it comes out again. So since this object is pulled to the left, okay, we'll let left be positive. Okay, it doesn't matter whether you take left or right as positive, but if you take left as positive here, the equation will be nicer. Okay, so let's look at the answer. First, what is the displacement at the beginning? Well, the displacement is x. Okay, as defined by here, and that's why it's so nicer to take left as positive, because it is displaced to the left, so the displacement is just simply x. If you have taken right as positive, then down here the displacement at this point will have to be minus x. Okay, but since you have taken left as positive and it was displaced to the left, the displacement is simply plus x, because it is displaced to the left. Okay, next, what is the force on the cut right now? Okay, since it's only moving horizontally, we only consider horizontal forces. Other forces like the weight and the normal, they are perpendicular to the horizontal, so we're not going to ignore it, because any dimension that's perpendicular to horizontal will not appear in our horizontal motion. So down here, we only look at horizontal forces. And right here, there's only one horizontal forces, and that's caused by the spring. Okay, we assume no friction, no air resistance, no nothing else. Okay, so there's only a spring. But this spring being compressed, it will tend to push out the cut. So the force here by the spring is going to be towards the right. So the force is going to be, and we know that this force is the spring force. Spring, we assume, obeys Hooke's law, so the spring force will be kx. And because the direction of the force is to the right, and we have taken left as positive, so the spring force in this case will be minus kx. Okay, we are following the sign convention. So once you have figured out the net force on the cut, which is minus kx, then our next step is to find out the acceleration. That we use the Newton's second law. Acceleration is F over m. So we have minus k over mx. Okay, this equation is the main thing. Is it proportional to x? Yes, because k and m, okay, we have to tell them k and m are constants, so acceleration is proportional to x. So that satisfies the first condition for being a simple harmonic motion, and that is the acceleration must be proportional to x. Does this satisfy the next condition for being a simple harmonic motion, and that is there a negative sign? Yes, there's a negative sign here. Okay, so the acceleration is in the opposite direction to the displacement from the equilibrium. So since it satisfies these two conditions, proportional and opposite, the oscillation is simple harmonic. Okay, so that answer the first part of question, show that the oscillation is simple harmonic. All we need to do is to work out the net force and then work out the acceleration and see if the acceleration is proportional to x and is opposite to x. Okay, if it is simple harmonic motion. Next, our second part of the question is, hence express the period t in terms of m, k, and x. Okay, once you get this equation, a equals to minus something x, this something is going to be our omega squared. Okay, so we shall equate this thing, KOM, as our omega squared. And we know that the period is 2 pi over omega. So 2 pi over square root of m over k. Okay, so that's the answer for example 11.